Right, so I'm going to go through your logs and exponential homework for you. Right, so question 1, we've been told that given that log to the base 10 of y is equal to 3 log to the base 10 of x plus log to the base 10 of 7, express y in terms of x. So a good place to start is just to copy out the question. So log to the base 10 of y is equal to 3 log to the base 10 of x plus log to the base 10 of 7. So on our right hand side, this side, we've got two expressions, we've got the same base, so we're going to be able to combine them together. But before we can do that, we need to get rid of this 3 at the front. So we know from one of our log rules that we can move that up, so we can that becomes log to the base 10 of x cubed, and then we still have the plus log to the base 10 of 7. Then on the other side we've got log to the base 10 of y. Okay, so when we've got two logs with the same base adding together, we can multiply kind of what's in there. So we get log to the base 10 of 7x cubed, and then we've got log to the base 10 of y on this side. So because we've got two expressions that both have log to the base 10, the log to the base 10s can vanish, and we get y equals 7x cubed. Okay, so for question 2, we've got log to the base p of p to the power of 5 times p to the power of 1/5, and we need to find the value of it. So the first thing we need to do is we need to sort our powers. So we need to sort these powers here. So when they're multiplying, what happens with our powers? What happens is we need to add our powers together. So we've got, over at the side, I'll do it a fifth plus 5, or 5 plus a fifth even, that way round. So the easiest thing to do is to change the fifth into, well, the 5 into fifths. Sorry. So 5 fifths is 25, so we end up with 26 over 5. So we get that's equal to log to the base p of p to the power of 26 over 5. So then we can take the 26 over 5 down the front, and then we've got log to the base p of p, which is just 1, so it's just 26 over 5. So that's just manipulating the powers for p, which is something you should be really good at from National 5. Okay, so for question 3, we've got a bit more complex a question. It's not more difficult, it's just they've been given it in words. So a radiation beam loses intensity after passing through an absorbing material of thickness x centimeters. The intensity of the emerging radiation beam I is given by the Beer-Lambert law, which is given there, where I naught is the initial intensity and mu, or that little u, is a positive constant. Okay, so if the emergent intensity is 50% of the initial intensity when x equals 9 centimeters, calculate mu. Okay, so we know that kind of what we're heading for. We need to use I equals I naught e to the negative mu x. So in the question we've been told that we know that x is equal to 9 centimeters for this one, and we've been told that the emergent intensity, so that's the I when it comes out, is equal to 50% of the initial intensity. So 50% is 0.5. Okay, so now we've got everything we need, so we can kind of substitute stuff in. So we get 0.5 I naught on this side is equal to I naught e to the negative 9 mu. That's just substituting in our values that we've got from the question. So then, because we've got an I naught on both sides, we can cancel them out. So we just get 0.5 is equal to e to the negative 9 mu. Right, so now what we do is we take the natural log of both sides, because that's going to help us get rid of our e. So we get natural log of 0.5 is equal to the natural log of e to the negative 9 mu. So then we can take that negative 9 mu down the front. And then the natural log of e is just 1, so that just vanishes as well. And then we get the log of 0.5 on the other side still. So we want mu on its own. So we have to divide by negative 9. So we have the natural log of 0.5 divided by negative 9, which, when we put that into our calculator, gives us 0.077. And then it's a 0, 1, it keeps going, but because it's a 0 after that, that's a good place to stop for our decimal places. So that's part A done. So for part B, we've been told for the material in A, so that is telling us that our x is still 9 centimeters. Our x hasn't changed, and our mu hasn't changed. Okay, and then it says calculate I when I naught is 2000. So this is really good. This is just putting this into our calculators, to be honest. But remember, we always need to show all of our working. So I equals I naught e to the negative mu x equals 2000 e to the negative, and then it's 0.077 times 9. Plug that into our calculators and we get 1000.147, and then that's fine. So I'll just round that to 1000.15. Okay, so let's think, does that make sense? So in the first part of our question, we found the emergent intensity, we got told it was 50% of the initial when x is 9. So if it's telling us that it's the same material, that means that our emergent intensity should be 50% of our initial one, because we've not changed anything other than we now know what's going in, so we know that what's coming out should be 50%. And you can see from our answer that we started with 2000 and we ended up with 1000, and we know that's half, which is 50%, so we've got it there, we've not made any mistakes. It's a good little just way of proving that we've got our answer right. Right, again, question 4 looks like it's much more complicated than it actually is. So, we've been told the pH of a solution is defined by pH equals negative log to the base 10 of H, where H is the hydronium ion concentration in moles per litre. That information, other than that equation and knowing how to use it, the rest of it, you don't need to understand, you just need to be able to pick out what we need to do and get on with it. So, not an arrow. We've been told that the pH of lemon juice is equal to 2, and H is what we're trying to find. So, from our equation we know that pH is equal to negative log to the base 10 of H. So that H is kind of caught up in that log, so we need to sort that out. So, we can substitute in our pH that we've got, so we're going to get 2 is equal to negative log to the base 10 of H. Okay, we don't like having that negative there, so we're going to move it to the other side. So you can think of it as you're multiplying both sides by negative 1. So then negative 1 times 2 is negative 2. Negative 1 times negative log is just log on its own, so you get log to the base 10 of H. And now we can rearrange. So we don't like that H being stuck inside the log, so we can take it out. And then the base comes up. And then we take our left hand side, and that becomes the new power. So the base comes up, and then your y, for example, becomes the power up here. So we can then put that into our calculators, and we get that H would be 0.01 moles per litre. Okay, that's the only kind of reason you need the moles per litre thing is because it is a calculation, it is an actual value, you need to put your units on it. Right, so for B, we need to find the pH. It's told us that oven cleaners are extremely effective if they have a pH bigger than 13.9, and it says Mr. Muscle has an H of 0. And then there's 13 zeros I've counted, and then a 1. Is Mr. Muscle an extremely effective oven cleaner? Justify your answer. Okay, so we need to find the pH of that oven cleaner. So we get the negative log to the base 10 of, and then 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1. Right, so at this point you have to be very, very careful putting this into your calculator, that you put in the right number of zeros. 6, 7, 8, 9, 10, 11, 12, 13, 1, there we go. And you get that the pH is 14 when you put that into your calculators. Okay, and then because it says justify your answer, that means you need like a wee sentence at the end. So the sentence you need is just to say, Mr. Muscle is an effective oven cleaner, or an extremely effective oven cleaner. Effective oven cleaner as its pH is 14, which is greater than 13.9. So seems pretty obvious, that sentence, but you need to put it there because the question asks you to justify your answer. That's saying, give me a sentence please. Okay, hope that's helped you with this homework. Well, congratulations for getting through the video. Thanks, bye.